Hi, good afternoon. These notes are on proportions, and this should be page 81 in our notebook for Unit 9. So go ahead and turn to that one. When we look on the inside, the notes right here are telling us that you can have an equation where you have one fraction is equal to another, but your denominator values cannot be 0, because when you divide by 0, you get an infinite answer, and that's not what we want. So right here, what we want to do is see if these ratios form a proportion. And what that's really saying is, are these equivalent? So 2 is to 10 as 5 is to 25. And there's different ways that we can do this. So I'm going to show you one way with this one and a different way with this one. So for right here, 2 to 10, if we reduce that, 2 to 10 is actually a 1 to 5 ratio. And 5 to 25 is also a 1 to 5 ratio. And then you ask yourself, is 1/5 equal to 1/5? The answer is yes, so therefore those are proportional. So that's one way that you can show proportionality when you're looking at fractions. Another way to show proportionality is you can cross multiply and see if you get the same value. So if I do 3 times 5, I get 15. And I do 10 times 6, I get 60. If those are the same value, then the answer is yes, we are proportional. If they are not, then the answer is no. So this would be a no, these are not proportional. This one was a yes. So that's a second way to show proportionality. A third way we could show proportionality is to come up with a common denominator. So 7 and 12, well, some common denominators between 7 and 12, I'm just going to multiply them times each other and get 84. So I'm going to change this to a denominator of 84. And I'm going to change this 12 to a denominator of 84. And that's just using my LCM rules. Well, if I change this to 84, that's 7 times 12. And so 3 times 12 is 36. And then to get from 12 to 84, I multiply times 7. And 5 times 7 is 35. If these fractions are equivalent, then I know that these are proportional. Well, 36 over 84 is not the same as 35 over 84, so these are not proportional. So it's a third way that you could figure out if two fractions are equivalent or are proportional. So 2 over 6 is equal to 5 over 15. There's 3 different ways we could do it. We can simplify them and see if they're the same. We can cross multiply to see if they're the same, or we can find a common denominator and see if they're the same. So we can try all 3 ways for this one. So let's first do where we simplify. So 2 over 6 can be reduced to 1 over 3. 5 over 15 can be reduced to 1 over 3. So right now, our answer is yes, these are proportional. That's one way. Let's do our second way where we cross multiply. 6 times 5 is 30. 2 times 15 is 30. 30 equals 30. That is equivalent, so those are proportional. And then the third way is find a common denominator. So 6 and 15, their common denominator is 30. So let's make denominator 30 for both. Well, if I'm going from 6 to 30, that's times 5. So 2 times 5 is 10. And if I go from 15 to 30, that's times 2. So 5 times 2 is 10. And 10 over 30 is equal to 10 over 30. Those are equivalent, so therefore they are proportional. So we were able to figure out 2/6 is proportional to 5 over 15, 3 different ways. All right, what if there's a variable involved? So solving proportions using cross products. A cross product is the product of the numerator of one ratio and the denominator of the other. So for example, AD is equal to BC. So it's basically what we did for this problem right here. So we're going to use the cross product method right here. So 9 times x is 9x. 4 times 27 is 108, I think. So 27 times 4. Yep, 108. And then look, now we have a nice one-step equation. We know how to solve this one-step equation. We need to divide both sides by 9. and x is equal to, well, 108 divided by 9 is 12. That's one way to do this proportion using the cross product. Now another way we could have done this problem, and I'm going to move it down to the bottom because I want to show you a really cool way. And this only works when you could see a relationship quickly. So the way I actually would have done this is not the cross product. I would have seen a relationship. So 4 to 9, I don't see a quick relationship, but 9 to 27, I do. How do you get from 9 to 27? You times by 3. Well, if I'm going to multiply the denominator times 3, I can multiply the numerator times 3. And what's 4 times 3? 12. So this method still gets me the same answer as when I did my cross product. It only works when there's a relationship that's very visible at first. If you don't see it right away, then you kind of have to do the cross product. So for example here, 30 to 20, I don't really see a relationship here. And 20 to 14, I don't see a relationship here. So the cross product might be the easier method. So we're going to do 20 times z, which is 20z. And 30 times 14, I'm going to use my calculator for that. And I get 420. And then now we have a nice one-step equation. The opposite of multiplying by 20 is dividing by 20. And whatever I do to one side, I do to the other. And 420 divided by 20 is 21. I'm going to actually show you another way we could have done this one. So down at the bottom. So let me show you. So 30 is to 20 as what is to 14. So something that I saw while I was working on that with you is I actually want to reduce this to 3 over 2 because 30 over 20 can be reduced to 3 over 2 is equal to z over 14. Now I see a relationship very easy. 20 is to 14 by multiplying times 7. So 3 times 7 gives me 21. So that was seeing a between relationship of the two denominators. So I saw that this was times by 7, so I multiplied that times 7, and that's how I got 21. So we got the same answer using the cross product up top. All right, let's do a couple more, and then you're going to do the rest on your own. So right here, I see a relationship really quickly. I see that this is times 3. So then I see that this is going to be times 3. And 2 times 3 gives me 6. So I know that A has to be 6. Another way we could do it is we could do the cross product. So 2 over 5 is equal to A over 15. So cross product is 5 times A is 5A. And 2 times 15 is 30. And then divide by 5 on both sides because we want to get the A by itself. So A is equal to 6. Notice how we got 6 in both methods. So A is 6. How you can check your answers is you can see if these give you the same fraction when reduced. So 2 divided by 5 is 0.4. And then 6 divided by 15 is also 0.4. So these are both worth 4/10. So I know that those are equivalent. All right, here I see a relationship with 4 and 12. So I know that this is times 3 or divide by 3. So I'm going to divide this by 3. So I'm going to also divide 96 by 3, and that will give me the value of C. So C is equal to 96 divided by 3, and 96 divided by 3 is 32. So I know that C has to be 32. That's, again, one way to do it. We can also do it the cross product. So let's write it. 4 over C equals 12 over 96. Cross product tells us to C times 12 and 4 times 96. The reason why sometimes I don't like cross products is because it does give us really large numbers to work with, and sometimes I don't like working with large numbers. So 4 times 96 gives me 384. Here's my nice one-step equation with multiplication. So to undo the multiply times 12, I'm going to divide by 12. And 384 divided by 12 gives me 32, which is what I got over here when I saw the relationship between. All right. Now this next one, I don't see a relationship easily. Like, I don't know anything 3 times what gives me 4 or 2.5 times what gives me 4. So I'm actually just going to do cross product straight away because I don't see a relationship in between. So 3 times 2.5 is 7.5. And 4 times y is 4y. There's my nice one-step equation. What's the opposite of multiplying times 4? Divide by 4. And 7.5 divided by 4 results in 1.875. So 1 and 875 thousandths. And that's the relationship there. All right, what I'm going to do is I'm going to jump down to one of the ones where the variable is not just x, it's 2x or 3x. There's a coefficient involved. So let's jump down here and let's try this one. So 2x times 15, so 2x times 15 is equal to 5 times 9. And then we just need to simplify that equation. 2x times 15 is 30x. And 5 times 9 is 45. That's a nice one-step equation. We know what to do next. We're going to divide by 30 on both sides. So x is equal to 1.5. So really what this is saying is 2 times 1.5 over 5 is the same as 9 over 15. What you're going to do is you're going to go ahead and try these 5 on your own, and then I will put an answer key up in just a moment. Now we're going to look up on the right side where we're doing word problems. So the word problems, what you have to do is you have to match them. So when you're writing a proportion from a word problem, make sure that they are matched. So if you're going to do points over games, it has to be points over games. If you're going to do points over points, then it has to be games over games. And you have to make sure that you do it in whatever order is the same. That way it stays proportional. So right here, 3 t-shirts for $54 is how many t-shirts for $126 or $162. So what we could do is number of t-shirts on top and your cost on bottom. Or you could do t-shirts to t-shirts over cost to cost. I always like to do my different units because I like to know kind of almost like the unit rate. So 3 t-shirts cost me $54. So how many t-shirts can I buy for $162? So what we can do is we can do a cross multiply and solve, or a cross product and solve, or we can look at a relationship here and here, or here and here. So for 3 shirts, it's $54. Well, I know that 3 can go into 54. So 54 divided by 3 is 18. So really each shirt costs 18 bucks. So I know that this is divide by 18. Well, that's divide by 18, then I can divide by 18 here as well, because it's $18 a shirt. So 162 divided by 18 gives me 9 shirts. So x equals 9. So our sentence could be 9 shirts for $162. So again, notice how I put the same units on top as I did on bottom. So t-shirts went on top, cost went on bottom. Number 2, if you get paid $75 for 5 hours, how much will you get paid for 3 hours? So the 2 things we're comparing is your payment versus your hours. So I'm going to put your payment up top and your hours on bottom. And I always like to make myself a little key over here so that I don't forget which one's on top and which one's on bottom. So $75, excuse me, is for 5 hours. And that is how much, we don't know, is for 3 hours. So what I can do is I can look at a relationship here to here, and I see that this is times 15. So this is times 15. And 3 times 15 is 45. So I'm going to get $45 for 3 hours of work. Okay? All right, what you're going to do is for the rest of the problems, you're going to try them on your own. Okay? And then we have one last thing to say as a class.
like it,